Hello everyone and welcome to my channel Chemistry by Miss Nidhi Banga. Today we will be talking about chapter 3 of grade 11, that is classification of elements and periodicity in properties. So let's get started. In this chapter we will talk about periodic table of elements. So this is our modern periodic table, and first we will get acquainted with it, get acquainted with the layout of this periodic table, and then we can get to the main objective of this video, which is for you to find out electronic configuration, group number, period number and block of any element in the periodic table. Alright, so but before that, let us get acquainted with the layout of periodic table because that is necessary. Right, so in this periodic table we have 7 rows. These 7 are the rows, horizontal rows, right? And they are called as periods. How many periods we have? We have 7 of them in total, and they give you the idea of the highest principal quantum number. That means, and highest principal quantum number is what? It tells you the outermost shell. So if you have any element and you have its electronic configuration, the highest shell, which is also the highest principal quantum number, is also the period number of that element. Okay, we have 7 of them. These 2 are not separate periods, they actually belong to these places. Okay, apart from the periods, we have these vertical columns, and we have all the way till here we have 18 of them, right? They are called as groups. We have in total 18 groups. These groups give you the idea of valence electrons in that element, right? Apart from groups and periods, we can also divide the periodic table into blocks, and those blocks will give you the idea like which the electron enters in which, last electron enters in which orbital, right? So let's get started. The first one we have is this one. Okay, these first 2 groups belong to S block, and it's called as S block because in these elements the last electron enters in the S orbital. Okay, now this one right here, this block is called as P block. P block because in all these elements the last electron enters in p orbital. Mind you, helium is not technically a p block element because the configuration of helium is 1s2, so the last electron enters in s orbital, but it's placed with rest of the noble gases because like all of them, it also has its shell complete. Okay, so helium is placed with noble gases because it behaves like them. Next up we have this block, this from group number 3 to group number 12. This block is called as D block because the last electron here enters the d orbital. And lastly we have this block. Okay, this is called as F block. F block because the last electron enters in the f orbital for all these elements. Right, now that you are familiarized with the blocks, remember the group numbers in those blocks. For example, the S block has the first 2 groups. Group number 3 to group number 12 is D block. Group number 13 to group number 18 is P block. And for F block, there is no group number because all of them belong basically here. So you can say that no group number or group number 3 for all of them, right? So with this information, let us get started. To write the electronic configuration, we would need to make sort of a cheat sheet. okay, which will help us a lot in writing the electronic configuration, and it doesn't take a long time to draw it. So practice it well. First you have 1s, then you have 2s and then 2p, then you have 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, and then 7s and 7p. We do not need to go any further. You'll see why. After drawing them, we will cross them diagonally like this. After that, we will write some numbers right next to them. We will write some numbers right next to them, and those numbers would be the atomic numbers by which that particular orbital is filled. For example, by atomic number 2, 1s is filled. By atomic number 4, 2s is completely filled. By atomic number 10, 2p is completely filled. Right? If you get the idea, let's get started. Then by atomic number 12, 3s is completely filled. Then we will move to 3p. Since p has 18 electrons, p has 6 electrons, 12 plus 6 would be 18. Then we will not move to 3d, we will move to 4s. That would be atomic number 20, by which 4s is completely filled. Then 30, 36, 38, 48, 54, 56, 70. 70 because 4f can or f orbitals can hold a maximum of 14 electrons. So 56 plus 14 is 70. Then 80 because then d can hold a maximum of 10 electrons. Then 86, 88. Here we would have 102. 88 plus 14 would be 102. 112 and 118. Now that's just how many elements we have in our periodic table, and that is why we do not need to go any further. After writing this, we will just highlight some special configurations, and those are these configurations. They are special because they will help us in writing the compacted form of electronic configuration, in which we mention the noble gases. So let's write the noble gases. Noble gases, we start with helium, but there's no point of mentioning helium in compacted electronic configuration, simply because writing helium in square bracket and writing 1s2 takes up the same amount of time, so we can skip it. Moving on to the next noble gas, that is neon. It can come right here, neon. Then we have argon. Then we have krypton. Then we have xenon, and finally we have radon. Right? So these noble gases will help us in writing the compacted electronic configuration. Now let us get started with some examples. Cesium, atomic number 55. Let's write the configuration. For that, we will see which noble gas falls before 55, and that is xenon. So we will write xenon in square bracket. And after that, since xenon is 54 and cesium is 55, we have just one more electron, which we will place in 6s1. Now, it's easy to find out the rest of the things with this configuration. So block would be S, simply because the last electron is entering in S block. Period would be the highest principal quantum number, which is 6. Highest value of n is 6 here. And you can check before 6s, all the numbers are smaller than 6. So period number would be 6. Group. Now group number here is first group of S block. First group of S block is the first group of periodic table. See? First group of S block is the first group of periodic table. So we can safely write group number 1. Okay, moving on to the next example, which is lead 82. Let us see the noble gas which falls before 82, that is xenon. So again, xenon and then 6s and then 4f till we get our 82. So xenon is 54, then 6s2 is 56, After that, we will have 4f14, 5d10, 4f14 and 5d10 completely filled. Here we have, till here we have atomic number 80. So the next two electrons will go in 6p, 6p2. Okay. Now, block number, p block of course, because the last electron is entering the p block. Period number, highest principal quantum number or highest n, which is 6. Group number. Now group number here is second group of p block. Second group of p block. But we know that before p block we have 12 other groups. Before p block starts we have 12 other groups. So 12 plus second group of p block, that means 14. So the group number would be 14. Let us see if we can place lead in 6th period and 14th group. Okay. 6th period, this one, and 14th group here. Okay, so lead is there in 6th period and 14th group. All right, next up we have iron. Iron atomic number 26. Let us write the electronic configuration. Let us see the noble gas before 26, and that is argon. After argon we have 4s and 3d. So let us write argon, atomic number 18. Then we have 4s, 20. Then we have 3d, 6. That makes it 26. Okay. Block number, of course, d block. Period number, the highest period number or highest principal quantum number is not 3, it is 4. So it would be 4th period. Group number, it is the 6th group of d block. 6th group of d block, and before d block there is s block which has 2 groups. So 2 plus 6 is your 8. Okay, so let us see if we can place iron in 4th period and 8th group. 4th period 1, 2, 3, 4 here, and 8th group here. This is our iron. Okay, moving on to the last example for today, uranium. Uranium atomic number 92. Let us see the noble gas before that, and that should be radon 86, right? After that we have 7s and 5f. Radon, 7s and 5f. This is radon 86. Then we have 7s, 88. Then we have 5f. 88 till 7s2. For making it 92, we have to add 4 electrons in 5f. Okay. Block number or block is f block, because the last electron enters in the f block. Period number would be 7th period. That means the last period. Group number, since it is f block element, the group number would remain 3rd for all of the f block elements, or you may choose to write just f block element. No mention of group would also be fine. So let us see if we can place it in the 7th period and 3rd group. So this is our 3rd group and 7th period meaning here. 3rd group meaning lanthanides and actinides. 7th period meaning actinides. Okay, and we have uranium in actinides. Okay, so I hope all of this helped, and if it did, please subscribe to my channel, like and share. Thank you so much. See you soon with the next video.